All right, so this is the lesson from earlier today. This is just a re-recording of it due to the fact that the other recording didn't get taken. It was had some issues. So today we talked about a couple different things about what a parameter and a statistic are. So let's first talk about parameter versus statistic. Okay. Both of these are it's ways of measuring your data. So if you have a population, if you're working with a population, meaning you're taking a census of everyone in that population, whatever it may be, remembering that a census can be expensive and difficult to complete, but any data you collect from that census is a parameter. Those are the numerical, so like if you find the mean, or later on when we talk about standard deviation, from a population, it's a parameter. These are the numerical values that we have. Okay. If we want to do something that's a little more realistic, like doing a sample, if we're finding a sample, that sample needs to be a representation of your population. It needs to be a good representation. To think of it as, let's say we're talking about the students at Whitney High School, and we want to take a survey. Well, would we just go and talk to all the freshmen? No, that probably wouldn't be a good idea because that's not representative of this whole student body. Now, there's ways of finding a good representation, and I'm going to talk about that in a few minutes. But you want to make sure you work and you get your sample to kind of so that you have a better idea of the true values that you get and the true inferences and things that you can make from your survey. So any of those values that you find from using the sample is called a statistic. Okay? So that's the basics of what a parameter is and what a statistic is. Parameter means it came from a population. A statistic came from a sample. So let's talk about the types of samples. And we're going to get into more detail about these types and some issues with them later, but we're just going to introduce the types. So the first one we're going to talk about is called a convenience sample. And the reason it's called a convenience sample is because it's convenient, it's easy. It would be like, so you're going to you have to go to the football game anyway, so you're going to pick people at the football game because it was easy to do. It doesn't mean it's going to be a good sample. You live near a park, so you go to the park and you talk to people at the park. It's convenient, but it may not give you a good representation of your of whatever you want to do. Okay? So it may not be as diverse. And may not give you that good representation that you want. Okay. Another one is called a cluster sample. And a cluster sample says you're going to take groups of people that have something in common. So you're going to use homogeneous groups. Where everyone in that group is surveyed. Example, so let's say they wanted to do a survey, for, again, students at Whitney. So again, let's say we're talking about Whitney High School. And so what happens is, let's say they pick my classroom, Mrs. Levitt's classroom, period 2. That means they would talk to everybody in period 2 of Mrs. Levitt's class. Let's say they pick period 4 of Miss Gack's class. Then they would talk to everybody in that class. That's a cluster, so they all have something in common, and they talk to everybody in that group. Now, a couple problems with the cluster sample is, depends on which classes they pick. They might pick, instead of my period 2, they pick my period 1, which is my AP Stats class. Maybe they pick a freshman PE class. Maybe they pick maybe the AP Calc class. You don't know. So sometimes you have to be a little careful with the cluster samples. And then the last one is the random sample that we're going to talk about. And a random sample is just that. It's where those surveyed are chosen by some form of random generator. So where those who are surveyed are chosen by a random generator, and I'll talk about that in just a second, what a random generator is. So let's say an example of a random sample is, let's say we took all the students from Whitney High School, we put them all in alphabetical order, and we say, because we want 100, we're going to go every 20th person gets picked. That's a random sample. There's less likely that you're going to get a whole group of the same type of people. It's not a guarantee. I mean, it's still never that thing's ever a guarantee, but it's more of a chance for you to get more of a representation of the student body. You could also, let's say you could use a rolling of a die to pick, or a flipping of a coin, something to choose, make your decisions. Many computers now, and most calculators, I should say, have a random number generator where you can randomly have the calculator pick numbers, and you choose those people that have a number assigned to them, making sure that you don't count repeats. Okay? And that's the basics of what I've talked about in class today. If you have any questions, talk to me tomorrow.